Hey guys, this is Miss Pasquale, or you know me as Sensei. I will be doing part 2 for your test number 10 on systems. And your test, remember, will be this Friday on the 28th. So I will be working on numbers 12 through 19 with you guys. And also my assistant, Jimmy, whether he likes it or not, will be helping us. Wake up. Let's begin.
Okay, so I'm still a little sleepy, so Sensei's having me lead off, so I'll wake up. So it looks like these first couple of problems are systems problems and they're word problems, so we're gonna have to read through these problems, get our important numbers, and assign them to where they're supposed to go. So,
With enthusiasm.
number 12.
Better.
167 tickets were sold for the class of 2007 ice cream picnic. Each student ticket cost $1 each, and each non-student ticket cost $2 each. A total of $240 was collected. How many student tickets were sold? So, we're definitely going to have to set up a system, but the first thing that we do before we actually set up those equations is define our variables. I'm going to have x represent the number of student tickets, and I'm going to let y represent the number of non-student tickets.
Remember, whenever you're setting up your variables, your unknown values are the variables. So think about what the question is asking. It's asking for how many student tickets were sold. But then I have also non-student tickets. So those are my unknown quantities. Therefore, those will be my variables.
So, on to setting up our equations. Usually when it comes to system equations, you're going to set up two different kinds of equations. In this particular case, there's going to be a quantity, or like a total number equation, and then there's going to be a cost equation, as in money is going to go with money. So when you actually set up these equations, make sure you set up that numbers go with numbers and money values go with money values. So let's look at our numbers first. 167 tickets were sold. So that's our number total. So let's go over to quantity, just put equals, and then 167 for the total number of tickets sold. That's part of our first equation. Now let's jump over here. A total of $240 was collected. So that goes to our cost equation. So we'll set equals 270. So now we have our total numbers. Now we just have to figure out which goes with which. Now, for our quantity equation, just because we have the total number of tickets sold over here, and x representing student tickets, and y representing non-student tickets, all that's going to be is x plus y will equal 167 tickets sold. As in, student tickets plus non-student tickets is the total number here. Now, onto cost. Here it says student tickets cost $1 each and non-student tickets were $2 each. So over here we'll just write 1 and 2. And when we write our equation we have to set it up so that it'll become 270. So x plus y again, because number of student tickets and non-student tickets, and then we're going to multiply each variable by the cost of their tickets. How many did the student tickets cost per? $1 each. So we'll just put a 1 here. And how much did the non-student tickets cost? $2 each, right? So a 2 in front of the y. And this is our system. Now, onto the meat of the question. How many student tickets were sold? In other words, we're going to have to figure out what that x is given this system of equations. It looks to me that the best method to solve this is going to be to use substitution. So I'm going to have x plus y equals 167 over here. And I'm going to solve for x, as in I'm going to have x equal to everything else. And I do that by getting x by itself. And how I do that is I'll subtract y over, cross that out, and what I'll have left is x equals 167 minus y. Now, since I have solved for x, I can actually substitute that into the second equation by taking all of this, whatever it's equal to, and put it in place of here. Okay? So, I'm going to rewrite all of it, and I'm going to show you what I replaced. So 1 parenthesis, and now I'm going to write in my Excel using this. 167, right, minus y. Close, because that's all the quantity contains. Then the rest of the equation. Now I can simplify and begin to solve for y. So 1 times 167 is just 167, and then 1 times that minus y is simply minus y. And then I bring the rest of the equation down because I haven't changed anything. I'm going to combine like terms. I'm going to move the entire equation up here. So 167 minus y plus 2y is going to be 1y, right? Equals 270. One step to go before we solve for y. We'll subtract 167 from both sides, and that'll leave us with y equals, let's see, that's 103. So y is 103, but so what was y? That was the number of our non-student tickets. And non-student tickets sold 103. However, the question wanted to know how many student tickets were sold, and we still have to find that number here. So let's go back to this equation. X plus y is 167. So let's just use that. X, because we still don't know it, plus y, which was 103.
Substitute it back in.
And that still equals 167. So we'll subtract 103 from both sides so that we just have our x value. And 167 minus 103 is 64. So number of student tickets sold was 64. Can I go back to sleep?
Now, anyway, in the meantime, I'm going to show you maybe a quick way. Maybe you're not comfortable with substitution. Because when you set up the equations, I have x's, then y's equals number. It's all in standard form. The cheating method, shh. The way you can cheat on this is just to use the graphing calculator, because it's already both in standard form. Let's say you have a dog named Alfie, all right? And you guys know about the Matrix. Well, if you don't, it's this really dangerous place. There's people jumping off buildings, there's shooting, there's death, there's violence. Anyway,
So cool.
Oh yeah. But you have a dog named Alfie, and he got lost in the Matrix. Oh no. If you're a caring owner, I doubt you'd want your dog to be lost in the Matrix. So first, let's make a plan of action. Let's create our Matrix. What are we going to input? All right, so we go back to our two equations, making sure they're both in standard form. The coefficient here in front of the x, it's not visible, but it's a 1. The coefficient here is a 1. Again, not visible, but still 1. And then the number here is 167. Second row, coefficient 1, coefficient 2, and number is 270. Okay, again, if it's in standard form, you just take out the letters, put in the numbers. Oh no, Alfie's lost in the matrix. So you have to go get him. But first you have to input the matrix. So go to second and x to the -1 power, because hidden up here is the matrix. That's the secret code. Alright, so we have to edit the matrix. We have to input it. So we go to scroll to highlight edit and press enter. Alright, this is a 2x3 matrix. Press enter. And we just enter our matrix from left to right. 1 enter, 1 enter, 167 enter. 1 enter, 2 enter, 270 enter. Guys see that? Yeah, there we go. That's better. Alright, I have inputted my matrix. Oh wait, hang on. You hear somebody coming. You gotta get out. You gotta get out of the matrix. Otherwise, you're gonna get killed. Go to second mode. Oh, you're safe. Oh, you're safe. Oh wait. You forgot Alfie. Gotta go back. Second matrix. And we want to find Alfie, but he has this kind of funny bark, and it sounds like ruff, ruff, ruff. So let's go to math. He's under here, but scroll up. You hear him, ruff. There he is, ruff, not ref, ruff. Option B, RREF. Oh, now we're safe. You've got Alfie. Oh wait, you forgot his collar. Gotta go back to the matrix. Second matrix, and oh, there it is. Right away, grab it, press enter, and enter again. And well, what do you know? X is 64 and Y is 103. Exactly what we got. Same answer, different method. Whichever one works for you, use it. Alright, so for number 13, we have the perimeter of a rectangle is 48 meters. The length of the rectangle is 3 times, so that's multiplication, the width. What are the dimensions of the rectangle? Meaning, what is the length and what is the width of the rectangle? Alright, so anytime you have a polygon problem, it's best to maybe draw a picture so you have a visual of what it kind of looks like. And this, of course, is a rectangle. Alright, so let's denote our variables. Let's let x represent our width. Whatever this width is, I don't know what it is, I'm going to call it x. So this will be the width. And let's let the length be y. Alright, so it says right here, it's length. So whatever y is, so I'll set that up. Its length is, so is means equals 3 times, so 3 times, so multiplication, the width, which is x. So this one is pretty much a direct translation from English into mathematics. Alright, so let's find the other equation then. The first bit of information it gives us is the perimeter, and we even give the hint, well, the perimeter formula is 2 times the length plus 2 times the width. So let's just use just that. So the perimeter in this case is 48. So we're going to replace P with 48. So I'm going to put 48 here. And then I have 2 times whatever my length is, which we said it was y. So I'm going to put y plus 2 times whatever my width is, which it said was x. And there you have your 2 equations. Ta-da! Now let's use these equations to find the length and the width. Now, the best method, I believe, for this setup for these equations would be substitution. Hey, look, you have a single variable and it's equal to some quantity. So let's circle whatever our single variable is equal to. So y is the same exact thing as 3x. So that means in the other equation, I'm going to substitute 3x in place of y. Because it says here y, it's the same exact thing as 3x. So it's like synonyms, you can replace them without changing the meaning. Alright, so I'm going to rewrite the second equation, but in terms of x. Here we have 48 equals to, but instead of y, we're going to put in a 3x. So switch them out. Alright, alright, and then you still have the plus 2x. Now you have your equation all in terms of x, you can simplify and solve. So first order business, parentheses, I gotta simplify this down. So, 48 is still here. 2 times 3x gives you 6x. And you still have this plus 2x. CLT, combined like terms, chicken, lettuce, tomato. Alright, 6x plus 2x gives you 8x. And then I still have this 48, bringing everything down. And then, to solve for x, I'm going to divide both sides by 8 because that's the opposite operation. And you would be left with x is equal to 48 divided by 8 gives you 6. So we said 6 is x. And x represents the width. So our width would be 6. And we have it in meters. Now that we have our width, we can find our length or our y value. Just plug it back into any one of these equations. Any one will work, but as problem solvers, we'll pick the easiest one. So let's choose the top one because it's more simple. So we have y is equal to 3, and I know what x is now. It's 6, so I'm going to plug it in here using parentheses. And all I have to do is simplify. 3 times 6 is 18. And so that is your length, 18 meters. Ta-da! On to the next problem, number 14. Here, Marcy has a total of 100 dimes, let's call this x, and quarters, let's call this y. If the total value of the coins is $14.05, how many quarters, so that's y, does she have? So in this one, we already defined our variables. Dimes will be x, and quarters will be y. So we need to find the value of y. So remember what Jimmy said. We will have a quantity equation and a total value or cost equation. So let's set that up now, shall we? So in the quantity equation, we have a total, so total is equals of 100 coins in general. Okay. So if x is the number of dimes and y is the number of quarters, then added together would give you 100. So all that is x plus y equals 100. And that's my first equation. Because I don't know how many dimes she has, and I don't know how many quarters she has, but added together gives you 100. Now for the second equation, that will be the cost equation, or the value. So speaking of value, let's talk about the value of dimes. Now dimes, we know, is 10 cents. And because it's written in dollar value, we want to be consistent. So instead of 10, we'll just put 0.10. Now same thing for quarters. Pardon my handwriting. Quarters, we know to be 25 cents. And we'll write it as 0.25. Now, to find the actual value of the amount that she has, well, we have the total value of all the coins being 1405. So let's write the total, which is equals 1405. So the total value is made up of dimes and quarters. But it's not the quantity, so I need to multiply it by its value. So the value of dimes, x, would be 0.10. So I'm going to write 0.10. Now the value of quarters will be 0.25. 0.25. And this amount gives you total value of all the dimes that she has. Because however many dimes she has, you multiply it by 0.10, and that will be the amount of money she has worth in dimes. Same thing here, but with quarters. So yay, we have our two equations. Now we need to find the value of y. So I'm just going to use my matrix again. Or you can use elimination or any method that works for you. But over here, because I see that both of these are lined up in standard form, x's, y's equals number, I'm going to create a matrix and just solve it that way. So let's write a plan of action. The coefficient here is 1. Coefficient here is 1. And the number here is 100. Coefficient here is 0.10. Coefficient here is 0.25. And the number here is 1405. So that's what I'm going to plug in to my matrix. Again, let's go plug it into the matrix. We have second, enter the matrix, and we have to edit it. Press enter. It is still a 2 by 3. And even though you have numbers already in there, you can just highlight it, highlight over it, and then just input it. It will overwrite all the numbers that you have in there. So here we have 1, enter, 1, enter, and 100, enter. Okay, that's our first row. Now for the second row, we have 0.10, we have 0.25, and we have 1405. So now that I have that entered in, remember second mode to get out of the matrix. Oh, forgot your dog. Go back into the matrix. Second matrix. And we got to find him. And he sounds like ruff, ruff. Option B. Oh, forgot his collar. Go to second matrix. Enter back into the matrix and grab it right away. Right there under the name. And your X value is the top one, 73. And your Y value is 27. So we have to go back to what the question is actually asking us. It's asking how many quarters does she have. So that's the Y value. And we found the Y value to be 27. So the answer is A.
Hey guys, I'm back for this one. So number 15, you go out to eat with your friend. You buy 2 hot dogs and 4 drinks for $8.50. And your friend buys 1 hot dog and 3 drinks for $5.50. What was the price of each item? So we're going to have to set up a system for this. So first off, let's define our variables. We have hot dogs and drinks. Let's just go ahead and assign variables to them. For hot dogs, we'll call them X, and drinks we'll call Y. So now we have to set up our system for this. So the system's going to be a little bit different compared to before because we don't have a quantity and a cost thing. But we have 2 individual, I guess, vendors or consumers that are buying the same product. And we just got to make sure that we keep the same quantity of products with that certain customer. So first off, let's do the equation for you. It says you buy 2 hot dogs and 4 drinks for a total of $8.50. So our total first, $8.50. And it says 2 hot dogs, 4 drinks. So remember, hot dogs are X and drinks are Y. Now we just have to assign the right quantity for each. Number of hot dogs was 2, and hot dogs was defined by X. And number of drinks bought defined by Y was 4. And that's the equation for your purchases. Now we have to do the same thing for your friend. So it says the total cost that your friend bought was $5.50, right? So we'll stick X and Y there for his hot dogs and drink spot. And how many did he buy? He bought 1 hot dog and 3 drinks. So hot dogs, X, he bought 1, and Y, he bought 3 drinks. So 3. So here's our system. Hey, this thing's in standard form. How about we cheat? So let's set up our matrix, right? Our 2 by 3. What are our numbers? 2, 4, 2, 4, and 850. So 8.50. And the second row, we have 1, 3, and 550. So let's create that matrix, okay? So remember, to get to our matrix, we press second and X to -1. That brings up our matrix menu. And scroll by pressing right twice to edit. Enter. 2 by 3 matrix. Set that up in case it's not that way for you. And let's input our numbers. 2, enter. 4, enter. 8.50, enter. Second row, 1, 3, and 5.5. So get out, then go back in get out by pressing second mode, and go back in by pressing second and then matrix again. Scroll over to math, press up and find your dog or something to that effect. Press enter. You've gone out. Now go back in one last time, second that inverse to go back to matrix, and you're on name, so press enter to bring our first one up and press enter. So that top row, we have an X value. That top row with the 1 here means this is the quantity or the cost of our X variable, which is $1.75. And on the second row with the 1 here, this means it's our Y. That's $1.25. So the cost of our products, hot dogs were $1.75 each, and the drinks were $1.25 each.
Yay! Okay, so for the next couple of problems, we are going to have to be solving these by graphing, hence the little grids that we provided on the right. Alright, so first what you need to know about graphing is, hey, before you even graph it, you need to make sure it is in the slope-intercept form, which is y equals mx plus b, where m is your slope and b is your y-intercept. Alright, that means we're going to have to solve for y on both of these. Alright, so I'm going to write each equation over here before we begin. Alright, so on this side, remember we want to solve for y. So we've got to box in our variable we want to solve for and anything that's attached to it. And remember guys, this is a -1 in front of it. Just because there's no number visible doesn't mean there is no number. Okay, so we put a 1 there, and this is hence a -1 for a coefficient. Now to move this outsider over to the other side, we've got to subtract it from both sides. So then you are left with -1y is equal to negative, and this is technically a -1x, just like we did over here, plus 6. It's a positive 6. We cannot combine unlike terms, so just put it side by side. Alright, now we are going to divide every single term by the coefficient. Those cancel out. You have a y is equal to -1 divided by -1 gives you a +1. So that's a 1 over 1x. So we know the rise over run. And then a +6 divided by -1 is a -6. So that's my slope, and that's my y-intercept. Now let's change this one into the slope-intercept form. Box in your variable and anything that's attached to it. Thank goodness this is a +1y, because now we don't even have to divide. Alright, so then we're just going to proceed to subtract both sides by 2x, which and then it cancels it out over here. And you are left with y equals, x is first, -2x minus 9. And the reason why I'm putting it all over 1 is because that will tell us the rise over run. If it's not a fraction, force it to be a fraction by putting it over 1. Now that we have both of our equations in slope-intercept form, we can go ahead and graph it. So I'm going to graph this one in red, and I'm going to graph this one in purple. So whenever we solve by graphing, we graph both lines on the same grid, and we see the point of intersection. Where do those two lines meet? Remember guys, whenever you're plotting lines, there are two main steps. Plot your y-intercept, and then do your rise over run in that form. So first, my y-intercept is a -6, so I'm going to drop 6 units down here. And then from there, that's my reference point to do my rise over run. So my rise over run over here is I'm going to rise 1, run 1. Rise 1, run 1, rise 1, run 1, etc., until I run out of room. And there's my line. Now I've got to plot the second line. This one, which I'm going to do in purple. Now the y-intercept on this one is a -9. So I'm going to plot it at -9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to drop 2 and then run 1. Oh, but I'm out of room. So instead of dropping 2 and running to the right one, I'm going to do the opposite. Up 2, but to the left one. So up 2 and to the left one. Oh, there's my point of intersection right there. Up 2 over 1, up 2 over 1. Alright, so my solution is the point of intersection. So that will be -1 for my x value, and -1, -2, -3, -4, -5, -6, -7 for my y value. And there's my solution, just by graphing. Now for the second one, again, I must put it in slope-intercept form. So I'm going to write them over here. 2x plus y is equal to 3. And I also have 4x plus 2y is equal to 6. Alright, so I've got to solve for y on this side. So I've got to box in my variable y and anything that's attached to it. Get rid of what's on the outside by subtracting 2x, subtracting 2x. Now you're left with y equals -2x plus 3. And remember, if your slope is not a fraction, force it to be a fraction by putting it over 1. I'm going to plot that right away. So my y-intercept is a 3. And from there, I do my slope, my rise over run. Drop 2 into the right one. Drop 2 into the right one. Drop 2 into the right one. Until you run out of room to the opposite. And there's my first line. Now for my second line, I need to solve for y again. So I've got a box in my variable I want to solve for, and anything that's attached to it through multiplication or division. Subtract 4x from both sides to get rid of it. Now you are left with 2y equals -4x plus 6, because it's a positive 6. I've got to divide every single term by 2. Divide by 2. 2 times 1 is just 2. Divide by 2. The 2's will cancel out. You're left with y equals, well, -4 divided by 2 does give you a -2. Again, put it over 1. And then 6 divided by 2 gives you a positive 3. And there's your new line. Here we have y-intercept at 3. Drop 2, run 1, drop 2, run 1. Hey guys, look, it's the same exact line. Oops. Same exact line. Don't you see we have the same exact equations? This is a special case, guys. If we have the same equation, therefore they are the same line. And if they are the same line, they share infinitely many points together. And that's what a solution means. A solution means which points do they have in common? At what point do they intersect or share the same point? And in this case, the solution is infinitely many points.
Okay, on to number 18. It looks like we have the system here, and 18 part A is asking what is the value of x in the solution of the to the system of linear equations above. So we have that top equation in standard form, and the bottom one is solved for y already. So why don't we go ahead and use substitution method since it's set up already. So we have a single y here and this y quantity here. So I'm going to substitute all of this into there. So writing that out, 7x minus I'm going to open parentheses showing that I'm substituting this in. So 5x plus 3. Close to show that I'm done substituting. Then write the rest of the equation as is. So now, firstly, I want to simplify this by getting rid of the parenthesis. Even though there's no number in front of it, that doesn't mean there's nothing there. There's actually a 1 there. Okay? So since it's minus 1, I'm going to distribute that, or rather, I'm going to start writing the equation again. So 7x, and now, so minus 1 times 5x, so that makes it negative 5x. Then distribute to the other one. Negative 1 times positive 3, negative times positive is a minus 3, equals negative 1. Next, I'm going to combine like terms, which are these two. So 7x minus 5x, that leaves behind 2x. Then there's nothing else to combine, so I'll leave the equation as is. And we have our good old two-step equation. So let's begin solving for x. And we solve x by going from the outside in. So plus 3 to both sides, cancels that. And I'm gonna rewrite everything up here. 2x, the 3 is gone now, right? So equals negative 1 plus 3 is positive 2. And now to solve for x, we'll simply divide by the number that's in front of x. Move. No, don't do that. Divide by the number that's in front of x. So we're left with x equals 2 divided by 2 is 1. So that's our x value. Now, part B, using the information found in part A, find the value of y in the solution to the system of equations. We'll take a look up here. We have an equation that's solves for y already, and we have an x value, which is 1. So let's take this equation, y equals 5x plus 3. I'm just rewriting it. And we know that x equals 1. So I'm just going to take this x value, plug it in there, and then we'll find our y. So y equals 5, substitute 1 plus 3. Y is equal to 5 times 1 is simply 5 plus 3. And so y equals 8. And that is our answer.
Alright, on to our last problem. Now, we have a taxi company A charges $4 plus 50 cents per mile. Taxi company B charges $5 plus 25 cents per mile. And how many miles will the taxi companies charge the same amount? So let's denote our variables. Let's let x be the number of miles, and let's let y be the charge after how many miles. Alright, so in this setup, both equations should be in the y equals mx plus b format, where m is the rate or the slope, and b is the starting point or your y-intercept. Alright, and the reason for that is because for each company, they give us a starting point and a rate, which fits the slope-intercept form, because the slope is the same thing as rate, and the y-intercept is the same thing as a starting fee, or your starting point. So let's make an equation for company A. For company A, they charge $4, so that's the starting amount, our B value, plus 50 cents per mile, so 0.5x, because it's a rate. Now for company B, we have our starting point to be $5, so it starts off at 5, and per mile they charge 25 cents. So we want to find the point of intersection between these two lines. At some point of time, company B will actually be cheaper than company A. The best method for this setup is just substitution. And if two quantities are equal to the same thing, that means they are equal to each other. Again, we're just going to use substitution. Bam. Set them equal to each other because they're equal to the same thing. So 0.5x plus 4 equals 0.25x plus 5. They're equal to the same thing, which is y. So they're equal to each other. So now we have an equation with variables on both sides. So let's move our variable over to one side only. So best method, move the smaller over to the larger. Alright, so 0.5 minus 0.25, or 50 cents minus 25 cents, is the same thing as 25 cents. And you still have this plus 4, and you still have this equals 5. Now you have your two-step equation. Box in your variable and anything that's attached to it through multiplication or division. Subtract. Now you're still left with 0.25x is equal to 1. And if you divide both sides by the coefficient, you get x is equal to 4. Again, guys, if you're not used to division with decimals or fractions, use your calculator. I'm not just pulling these numbers out from my butt. These are the actual values. X is 4. So the question was asking, in how many miles will the taxi companies charge the same amount? And well, what do you know? We already found that value. In 4 miles, they will charge the same amount.